Service entrance. Service terminology. The service entrance cable, SEC, is a line of service conductors located between the terminals of the service equipment, main disconnect, and a point usually outside the building, clear of building walls, where they are joined by a tap or splice to the service drop or overhead service conductors. Please refer to the service entrance image in the course for a visual representation. The blue arrow in this image is pointing to a protected or sheathed SE service entrance cable. The service point is the point of connection between the facilities of the service utility and the premises wiring. The overhead service conductors are also the overhead conductors between the service point and the first point of connection to the service entrance conductor at the structure. The service equipment is the necessary equipment, usually consisting of circuit breakers or switches and fuses and their accessories, connected to the load end of service conductors to a building or designated area, and intended to constitute the main control and cutoff of the supply. It is understood that raceways, fittings, and enclosures housing service conductors are also part of the service equipment. Meter socket enclosures are not considered service equipment. Meter enclosures do not have interrupting ratings, disconnecting means, or overcurrent protection. Again, please refer to the image in the service entrance service terminology section of the electrical course. In the 2018 International Residential Code, or IRC, section E3501.1, are defined as the overhead service conductors between the utility electric supply system and the service point, which is the orange arrows in the image. The white arrows are also service conductors. They are referred to as overhead service entrance conductors. They are the service conductors between the terminals of the service equipment and a point usually outside of the building, clear of building walls, where joined by a tap or splice to the service drop of overhead service conductors. The important commonly used terms for home inspectors are overhead service conductors, the service entrance conductors, and the splice. Service drop. The service drop is the overhead service conductors located between the utility electric supply system and the service point. Service point. The service point is the point of connection between the facilities of service utility and the wiring at the house. Service point. The service point is the point of connection between the facilities of the service utility and the wiring at the house. The point of attachment of the overhead service conductors to a building or other structure should be not less than 10 feet above finished grade, or 3,048 millimeters. Overhead service. In many older residential areas and practically all rural locations, the electrical supply is delivered to the property via overhead conductors strung on wooden utility poles. The high-voltage lines connect directly to the property through a transformer delivering main power. While the service overhead belongs to the utility company, the inspector should still evaluate it, particularly to determine the available voltage, its clearances, and any mechanical damage. The cable assembly. Most residential buildings are supplied with 120-240-volt services. This means that the cable assembly is made up of two ungrounded, live or hot, conductors, each supplying 120 volts with one neutral or grounded conductor acting as the return. Many homeowners mistakenly believe that the three conductors include one each of a live, a neutral, and a ground. In fact, to have 240 volts available in the home, we need two separately derived 120-volt undergrounded conductors and a grounded conductor. The ground does not return to the pole through the cable assembly. The grounded conductor serves the role of the return path to the transformer. There are, however, a few variations on the theme. It is not unusual to see one of the live conductors tied back. This is indicative of a 120-volt only supply, which is still installed in some older properties, apartments, and condos. Conversely, the inspector may see cable assemblies with more than 3 connected conductors. This is typically a 3-phase supply, commonly found in both commercial and agricultural environments. In the case of 120-volt only supply, We recommend that the inspector's report shows this limitation. In the case of high-voltage, three-phase supplies, we recommend that the inspector defers this part of the electrical inspection to a qualified industrial or commercial electrical contractor. The service cables are connected to the service entrance cables by crimped connectors, which are then covered in an insulated sleeve. The neutral, grounded conductor also serves as the main physical connection, though insulated, to the building. The inspector should ensure that this strain relief is not detached or pulling away from the structure. On some older properties, the conductors are not in an assembly and each has its own connection to the structure, but this is rare these days and probably in need of replacement. The point of attachment of the service drop conductors to a building or structure must have a clearance above the finished grade of at least 10 feet. The overhead service must have some minimum separation from both the structure itself and any walkways, driveways, balconies, patios, and swimming pools. Very often, an inspector will see properties that have been modified and the service overhead should have been relocated but wasn't. This can obviously lead to some dangerous conditions, especially over swimming pools and decks where the service connections could be accidentally reached by the homeowner. Please refer to the Service Drop Clearances section in the course for images of service drop clearances and a table with further information on the vertical clearance from grade or open overhead service conductors. Conductors must have a vertical clearance of at least 8 feet above the roof surface with a distance of at least 3 feet in all directions from the roof's edge. There is an exception for low-sloped roofs or flat roofs with a surface accessible to pedestrians, such as a balcony or deck. Overhead service conductors, supported on and cabled together with a grounded bare messenger wire above a roof surface subject to pedestrian traffic, must have a vertical clearance from the roof surface of at least 10 feet. The minimum vertical clearance must be at least 10 feet at the electric service entrance to the buildings, at the lowest point of the drip loop of the building electric entrance, and above areas or sidewalks accessed by pedestrians only. Such clearance shall be measured from the final grade or other accessible surfaces, such as a deck or balcony surface. If it's just a flat roof with no pedestrian access, then the clearance is 8 feet. Another common clearance problem is caused by trees and shrubs interfering with the overhead supply. The inspector should take the time to eyeball the length of the supply from the pole to the attachment point on the structure and report any tree limbs touching the conductors. Also remember that the branches are heavier during the summer and weigh down further on the conductors. What may be marginal during the winter months may well cause a problem later in the growing season. The inspector should recommend that any limbs within 5 to 6 feet of the cable assembly be cut back. Service mast and attachments. In most cases where the home is fed by a service overhead, the supply is fed down the outside of the house through a conduit known as the service mast. In some cases, the cable assembly is of a type SE, which requires no conduit. Masthead. The masthead, or gooseneck as it is sometimes called, is at the top of the mast itself. Its purpose is twofold. First, to act as a rain cap to stop moisture from entering the conduit, and second, to provide the bushings to prevent the individual conductors from being damaged by rubbing against the metal components. In electrical power situation, a bushing is an insulated device that allows an electrical conductor to pass through something else that may be conductive. The masthead should be undamaged and securely fastened to the service mast. The inspector should report any loose fittings or cracks in the masthead and its clamp. Please refer to the images in the course for examples of damaged mastheads. Before the conductors enter the service mast, there should be a loop in the conductors. The lowest point of these loops should be 12 inches below the point of entry into the masthead itself. This is to prevent rainwater from migrating along the conductors or cable assembly and pouring down into the masthead. Service masts for supporting the service drop and overhead service conductors should be of adequate strength or be supported by braces or guy wires. A mast in excess of 3 feet above a roof surface may require support. The weight of the cable assembly is considerable and, when applied to an overly tall mast, has the ability to bend it right over. For the same reason, the inspector should report anything other than the cable assembly being supported by the service mast. It is far from uncommon to see telephone cables, TV cables, satellite dishes, clotheslines, and supplies to remote buildings being supported by the service mast. The inspector should report all of these as in need of repair or relocation. Service mast flashings. As with any other projection through the roof surface, the service mast should be adequately flashed to prevent water from entering the building. It is not unusual to see signs of water leakage through the roof due to poor mast flashings. Because the mast is generally outside of the conditioned space, these leaks commonly go on for years, causing considerable damage to the roof sheathing and fascia. Again, please refer to the online course for images of defects. In the case of rigid conduit service masts, they should be attached to the structure every 5 to 6 feet throughout their length and should also have a clamp within 12 inches of either side of the meter base, as well as at the top of the mast, if it doesn't project through the roof. It is all too common to see the attached clamps not replaced or loose after the building siding has been replaced. Any defects in this area should be reported as in need of repair by a licensed electrical contractor. Type SE cable. The SE in SE cable stands for service entrance. This cable assembly is designed with a high degree of resistance to mechanical damage and the sun's UV, ultraviolet rays. For this reason, it is not installed in a conduit, but is attached directly to the building. If the SE cable is located someplace where it is likely to be subject to physical damage from car doors, etc., then it must be protected by a conduit. It should still feature a gooseneck or service head cap, and the end where the individual conductors exit the sheathing should be protected from moisture intrusion by a heat-shrunk sock if a gooseneck is used. This type of cable should be attached to the building every 30 inches along its length and within a foot of its top, and any meter can. Service lateral. Underground service supply. As previously discussed, in most newer and densely populated areas, the electrical supply is fed underground. This is properly called a service lateral. Other than during the very early stages of construction, the home inspector is not able to evaluate the conduit or cable, but for informational purposes, there are some restrictions that apply to underground services that should be noted. Direct burial cable. Type UF cable is rated for direct burial and has outer sheathing that is resistant to moisture and damage from soil. This type of cable must be buried to a depth of 18 to 24 inches, depending on the location, and if embedded in rocky ground, must be installed in a manner that will not damage the cable. This cable still needs to rise in a conduit to prevent mechanical damage before it enters the building. The visible conduit should be made of either galvanized steel or gray plastic, rated for the purpose. Underground conduit. Where the service entrance cable is not rated for direct burial, it needs to be in a full conduit and must be buried at a minimum depth of 18 inches under landscape and 24 inches under hardscape, such as driveways. Where the service conductors are buried underground, they are required to have a ribbon embedded 12 inches above the conductor unless they are under the exclusive control of the utility company. In residential construction, there would be only one conduit. Above-ground connection. The home inspector should evaluate any visible above-ground conduits and report any damage or open joints that would allow moisture into the assembly. Electric meter. Electric meters and bases. The electric meter is normally part of the service entrance equipment. It is there to measure the amount of power used on the property. Some properties may have more than one meter, maybe due to multiple occupancy or discounted power for heating use. As the meter is a rated component like any other, the ampacity of the meter and its base cannot be lower than the total available amperage. We will look at this further in the next section. The very earliest meters had no separate base and are typically rated for only 30 amp supply. Round meter bases. Common from the 1920s up to the 1950s, they were rated for only 60 amps and are still often seen on older properties. Square meter bases. Typically found on homes from the 1950s to the 1970s, these are still used in some smaller housing units, such as apartments, and were only rated for 100 to 125 amps. Rectangular meter bases are the current minimum on single-family homes. These are rated for 200 amps and typically bear the marking 200CL. Understanding meter bases is an important part of being able to properly evaluate the maximum available amperage in the home, but should not be relied on completely when sizing a service. Typical meter installations. Please refer to the images in the electric meter section of the course for images of multiple 60 amp round meter bases, 100 amp square meter bases, and a modern 200 amp rectangular meter base. The service entrance cable, or SEC, is the conductor assembly that connects from the service supply through the meter socket and onto the primary disconnecting means. Obviously, the conductors are another rated component, and the home inspector needs to be familiar with the current carrying capacity of the various sizes of cables. Conductor materials. Service entrance conductors, like all others, are made from either copper or aluminum. As discussed previously, aluminum conductors need to be sized larger than copper ones for any given amperage. Aluminum terminations may also be coated with an antioxidant to prevent corrosion, although the more recent AA 8000 aluminum alloy conductors do not require it. The use of copper is the most common since it is the default conductor by code, but aluminum is popular for services when cost is an issue. Service entrance conductor ampacity. Please refer to the table in the course for the common cable sizes for both copper and aluminum together with their ampacity and wire size. Note: increasing gauge numbers provides decreasing wire diameters. For example, when the diameter of a wire is doubled, the AWG decreases by 6. The AWG sizes are for single, solid, round conductors. The AWG of a stranded wire is determined by the total cross-sectional area of the conductor, which determines the current carrying capacity and electrical resistance. The stranded wire is about 5% larger in overall diameter than a solid wire of the same AWG. 100 amp to 400 amp services are based on 3-wire 12240 volt systems and 310.15 B6 of the NEC. AWG stands for American Wire Gauge, also known as the Brown and Sharp wire gauge. It's a standardized wire gauge system used in the US and Canada. AWG is referred to as a gauge, and the zeros in large wire sizes are referred to as aught. Wire sized 1 AWG is referred to as 1 gauge, or number 1 wire. Smaller diameter wires are called X gauge, or number X wire, where X is the positive integer AWG number. Number O, written 1/O, is referred to as 1/aught wire. 2/O is referred to as 2/aught, and so on. KC mil. This wire size is the equivalent cross-sectional area in thousands of circular mils. A circular mil is the area of a circle with a diameter of 1/1000th of an inch. In North America, conductors larger than 4/aught AWG are typically identified by KC mil.